Hello, today we're going to talk about reactivity 3.4.3, and this one is about heterolytic fission. So heterolytic fission is when you are breaking a bond, but one atom is going to receive both of the electrons that were shared in the bond. So an example would be if you have like chlorine, two chlorines attached. You can break that apart into a positive ion and a negative ion because one of the chlorines doesn't get any electrons from the bond and the other chlorine gets both of the electrons from the bond. Another example would be something like HCl, splitting the bond. And when it splits apart, the hydrogen would not gain the electrons, but the chloride would. And that's because chlorine is more electronegative than hydrogen. We can also represent the movement of electrons, of course, with curly arrows. Remember, you always show the electrons going from where they are starting to where they are heading. So in this case, the electrons are going from the bond to the chlorine to break that bond, from the bond to one of the chlorines. And so those are the basics of heterolytic fission. So this example has us using curly arrows to explain the difference between homolytic and heterolytic fission, specifically for HBr. So I will draw two HBr molecules so we can look at the difference. And remember, homolytic, each atom is going to get one of the two electrons shared in the bond. So we will use these half arrows, or some people will call them fish hooks, because it's showing that there's only half of the pair, so only a single electron going to each. So you will wind up in the creation of radicals, free radicals, like this. For heterolytic fission, all of the electrons will go to one of the two atoms. So we want to use a normal arrow to indicate that both electrons are moving, and you will be left with ions as a result of that bond breaking. And bromine will get both of the electrons. And this, of course, links to Reactivity 3.3, where we talked about free radicals and their reactions. So the bond breaking that forms a radical is homolytic fission, usually requires UV light. And then bond breaking that occurs for nucleophilic substitution reactions is heterolytic fission. So one of the two atoms will gain both of the electrons from the bond.